Hello students. In this video, we'll try to understand the first law of thermodynamics. Beginning with internal energy. Internal energy of a system is the sum of the kinetic energies of all of its constituent particles plus the sum of all the potential energies of interaction among these particles. Now let's consider a simple thermodynamic system, a cylinder with gas enclosed in it. Now these are the gas molecules. Now they have kinetic energy due to its rotation, vibration or translation motion. Potential energy is due to the interaction among these particles. Now the sum of the kinetic energy and the potential energy would give you the internal energy of the system. Now let's try to move this system as a whole with a velocity v. Obviously, the system has gained a kinetic energy half mv squared. But that kinetic energy will not contribute to the internal energy of the system. Likewise, if there is a table and I'm trying to place the whole system, the cylinder, on the table, the gravitational potential energy has changed, but this will not change the internal energy of the system because internal energy is concerned with the molecular kinetic and potential energy. It has nothing to do with how the system interacts with its surroundings. So it's a state variable because it depends on the state of the system. It can also be called as a macroscopic variable like pressure, volume, or temperature. Now regarding heat and work. The same system, the cylinder with gas molecules inside. Now additionally, a piston is provided to the system. What would happen to the kinetic energy and potential energy of the gas molecules? Obviously, the system as a whole is disturbed, so they get compressed, and because of that, the internal energy of the system changes. Now, if I'm trying to heat the gas, the kinetic energy of the system, the translation, rotation, vibration, everything increases, which would again increase the internal energy of the system. And it is a gas, so due to this heat, the gas can expand. So because of that expansion, a pressure can be exerted on the pistons. That is, work can be done by the system as well. So that would also result in the change of the state of the system or the internal energy. Now, if I remove the heat, the already heated system will begin to cool down. So as a result, heat would be rejected from the system. Again, this would also result in the change of the internal energy. So what I mean to say is that work done on the system, by the system, and heat supplied into the system and heat rejected from the system can all change the internal energy of the system. So then what is heat and work? They are two different modes of altering the system state and changing its internal energy. And they are not functions of the state of the system. That's why we say heat supplied to the system or heat rejected from the system, work done by the system or on the system. We do not say heat of the system because it's not a property that is contained by the system. Then what are they? They are energy of transit. What is heat? Heat is a measure of energy which is transferred from one system to another as a result of the difference in temperature. How about work? Work is force into displacement. So the point of contact of the force exerted by one system on the other undergoes a displacement. So again, work is a measure of energy. So heat and work are two different forms of energy. Now with these concepts in your mind, we'll try to understand the first law of thermodynamics. It states that the energy supplied to the system goes in partly to increase the internal energy of the system and the rest in work on the environment. That is, delta Q equals delta U plus delta W. Delta Q is the heat supplied to the system. So that part of that energy is used to increase the internal energy and the rest would be mechanical work. So whatever energy supplied to the system is completely used by the system. Energy is neither created nor destroyed. Therefore, it is also called as the principle of conservation of energy. Now, based on the first law of thermodynamics, let's try to explain why do we exercise. So our body is a thermodynamic system. So this man, he's trying to do a push-up. So he's trying to lift his body. So work is done by the system. So when work is done by the system, by sign convention, it is positive. Delta W is positive. And also when you do exercise, your body warms up. So heat is rejected from the system to the surroundings. Is it not? Then delta Q would be negative by sign convention. So how about the change in internal energy? Change in internal energy would also be negative, which means that it would decrease. That means the internal energy in our body, which is stored in the form of fat, gets burned up when we do exercise. That's why we do exercises. Thank you and see you in the next video.